today we'll see rest of the architecture part. So as we already saw, SGA, first we have a fixed SGA part, which serves as a kernel for the SGA, which will build rest of the SGA components. And then we have database buffer cache, shade pool, and this is in turn divided into two components, library cache and dictionary cache. And then we have a log buffer. It's log buffer, actually it will be in circular form, so I'll make it circle, and this will be a log buffer. And then some of the optional components we already saw, stream spool, Java pool, and latch pool. So do you guys have any doubts, any questions till this part? And this database buffer cache, it's already divided into default buffer cache or db_nk_cache. So I'll make it into two. One is default buffer cache, and the other one is db_nk_cache size. So till this one, I mean, like, do you have any questions on these components? If not, I'll move forward.
Yeah, I'm going to that videos, Mohan. I'm good. Like, you can go ahead. I mean, ask for my concern.
Okay, sure. Ashish, do you add also?
Hey, move forward.
Okay. Okay then. So there are some other components in the SGA itself. One of the component is keep buffer cache. Keep buffer cache, and the other one is recycle buffer cache. Even these are optional components. You can configure it or not depending upon your requirement. So we'll see what are these components. So we already saw whenever server process unable to find any free buffers in the database buffer cache, it invokes dbwr to write the dirty buffers from the buffer cache to data files. Correct? So in that case, the object which is present in the least recently used end will be written back to the data file. What are the modified buffers which are related to that least recently used object? That will be written back to the data files. If you don't want dbwr to write the content or to flush the content from buffer cache to data files, or if you see here, if server process doesn't find any free buffers in the buffer cache, first it will find the object which is present in the least recently used end list, and in that object it will only write the content which are dirty buffers. If the buffers are clean buffers, then it will just flush it from the buffer cache. So if you don't want your object to be flushed from the memory, if you want your object to be always present in the memory, then you will go ahead and create an object with keep buffer cache option. So whenever you create an object, and while creating the object itself, when you specify it to store it in keep buffer cache, it will not be flushed from the memory until and unless you shut down the database. Rest of all the times the object will be present in the memory itself. So those kind of objects will be always be present in the memory. So for example, if you have any smaller table, or if the table is important to the application, application frequently access that object. In that case, we will keep the objects in the keep buffer cache, such that object will always be available in the memory, and users can retrieve the data in a faster way. So whatever the data buffers DBWR writes from the buffer cache to the data files, it will not be applicable to the keep buffer cache. Always the objects will be present in the memory itself. So in order to create the objects in the keep buffer cache, we will create table, uh, keep underscore demo, application ID, application name, varchar2 of 10. After that, we will have an option or clause called as storage clause. In the storage clause, we will specify it as keep buffer. The moment you have the keep buffer keyword used, buffer pool keep. Buffer pool keep, sorry. So the moment you add buffer pool keep clause into the storage section, whenever the object will be present in the keep buffer cache. So once you access this object, server process will not place the object from the data files to the database buffer cache. It will place the object into keep buffer cache. As a result, the object will always be present in the memory. And recycle cache, it works in a similar way but quite opposite. So the moment you access it, once you finish your transaction, then immediately the object will be flushed from the recycle cache. So whenever you create an object with the storage class equal to buffer pool recycle, then once you finish your transaction, once you finish accessing that object, it will be flushed from the memory to the data files. It will not wait until there are no free buffers available in the buffer cache. Straight away, the object will be flushed from the recycle cache to data files. So to create an object with recycle option, we'll go for buffer pool recycle. So if the object is frequently accessed, then it's better to keep the object in keep buffer cache. If the object is not frequently accessed and it is not important to the application, then you can create an object with recycle cache option, such that once you access the object, it will be flushed from the memory. Then and you already know this part will be variable SGA. That means each of the component size can be changed. Apart from the fixed SGA, each of the individual component like database buffer cache size or streams pool size or Java pool size, you can change depending upon your requirement. So that is the reason why it is called as variable SGA. Now, within this variable SGA, you have two types of components. One is dynamic component, and the second type of component is static component. So static component, in the sense you can change the value of the component, but the thing is, like, if the database is running. That means instance is already allocated for the database. And if you want to change the size of that component, it will be reflected only after the reboot. So once you shut down the database and you bring it up again, the change will be affected. If the initial size of one of that component, one of the static component is log buffer. So initial size of log buffer, say for example, if it is 4 MB. Now, if you want to change the size of log buffer to 8 MB, you cannot change when the database is up and running. That means when the database is up and running, you cannot change the size from 4 MB to 8 MB immediately. You can change the parameter in the, like just in couple of minutes you will know what is a parameter. You can change the parameter in order to change the size, but the change will be affected only after the bounce. That means the change will be affected only after restarting the database. So those kind of components are called as static components. The components which can be the components for which the size can be changed only after the reboot, those components are called as static components. And dynamic components are the components for which you can change the size on a fly. So even the database is up and running, you can change the component size. So those kind of components are called as dynamic components. So coming to static components, you have two components. One is log buffer. Yep, only one component which is static, that is log buffer. Log buffer component is a static component, and then the dynamic components are rest of the components are dynamic components. That means the rest of the components you can change the size on the fly. The moment you change the parameter, the change will be affected in the SGA. If the initial size of database buffer cache is 100 MB, and if you want to increase the size to 200 MB, the moment you change the parameter in the SGA, change will be done such that the database buffer cache size will be 200 MB. So this is 11G part. In 11G, starting from 11G, we only have one static component in the SGA, which is log buffer. In 10G, db underscore nk underscore cache size. This is a static component. And also log buffer. So these are the two static components in 10G. Coming to 11G, even db nk cache size we can change dynamically. So this is one of the difference between 10G and 11G versions. Next. So how the size will be allocated for each and how much of space will be allocated for each and every component in the SGA. So SGA is nothing but it's a large chunk of memory which is allocated in the memory. So now how much of space in the memory will be allocated for each and every component. So it depends upon how you configure them. So there are some parameters using which you'll configure each and every component of the SGA. So to determine or to configure the database buffer cache, to configure the default buffer cache, we will use the parameter db underscore cache underscore size. This is a parameter which will determine the size of database buffer cache. Next, coming to streams pool, streams underscore pool underscore size. This parameter will determine the stream spool size. Next, shade pool size will be determined using the parameter shade underscore pool underscore size. In a similar way, log buffer will be determined using the parameter log underscore buffer. Java underscore pool underscore size. And large pool will be determined using large underscore pool underscore size. And this is the only static component of the SGA, log underscore buffer. And as we know, these are the parameters which can be used in order to configure the each and every component of the SGA. Now, where these parameters are stored, how Oracle will read these parameters in order to allocate the SGA. So whenever you issue the startup command, so to start the database, you always log into the SQL Plus utility and you will issue the startup. You will connect to the SQL Plus utility and you will issue the startup command, correct? So whenever you do this, Oracle will look for a physical file. This will be the first step Oracle will perform whenever you issue the startup command. So it will look for a physical file which is called as parameter file. So this is one of the physical files corresponding to the database, and this physical file will always be present in Oracle home /dbs location, and the file name will be of the format init sid.ora or spfile sid.ora. There are two types of parameter files. There are two types of parameter files. One is init file, which is called as p file. The other one is sp file. It's called as sp file itself. Now, there are some difference between a p file and an sp file. P file, it's a parameter file. The full form of p file, it's a parameter file, and it can be in any of the location. As I said just now, the parameter file needs to be in Oracle home /dbs. If you are using a p file, that is not the case. By default, Oracle will look for a p file in Oracle home /dbs location. So whenever you issue the startup command, it will look for a p file which is present in Oracle home /dbs. If the p file is not present in Oracle home /dbs, you can specify from where p file must be read in order to perform the startup command. So you have an option. You can specify the location where the p file is present if it is not present in Oracle home /dbs. By default, Oracle will look for the parameter file in Oracle home/dbs folder. But if you have a parameter file in a different location, you can specify the location. Coming to SP file, it should always be present in Oracle home/dbs. You don't have the option to specify the location of the SP file. So this is one of the difference between a P file and SP file. P file can be in any location, and you can specify that location while performing a startup. SP file, it will be in Oracle home/dbs location, and there are several advantages with using SP file. You will know that in the future classes, and this SP file is introduced from Oracle 10G. In the earlier versions, we only have the P file. So there were some disadvantages with the P file. To overcome those disadvantages, Oracle introduced SP file concept, and that you'll know in the future classes. What are those advantages and what are the drawbacks of P file? But for now, just remember it will be present in Oracle home/dbs, or Oracle will look into that folder in order to perform the startup. And this will be the file format. It will be init sid.ora, and you already know sid will be instance name. SID full form is site identifier, and it is called as instance name. So if you have a database with the name test, then you will have either a P file with init test.ora or SP file test.ora, and you'll use only one of these files, not both the files. So we'll usually, starting from 10G, Oracle recommends to use SP file. So we will use this file, and this file will be present in Oracle home/dbs. And in this parameter file, you will have content in the format of key and value pairs. So key will be parameter name, and value will be the actual value assigned to that parameter. So the parameters which we saw till now, like db underscore cache underscore size, log underscore buffer, large pool size, streams pool size, shade pool size. All these are called as keys, and you will assign a value to these keys. So for example, if you want to specify 100 MB for database buffer cache, then you will specify 100 MB here. Then for log buffer, 4 MB. For large pool size, if you want to go for 50 MB, you can specify 50 MB. Streams pool, you can specify 100 MB. And shade pool size, streams pool and large pool, you can go for a little, like smaller value, because those are optional components and those will be used. For example, if you take large pool, it will be used whenever you perform the backup, and streams pool will be used whenever you use Oracle streams. So for those components, we'll specify very small amount of size, and you already know log buffer should be in the smaller size, because content from the log buffer will be written back to the physical files, which are called as redo log files, for each and every 3 seconds. So that is the reason why there is no need of specifying a bigger size for log buffer. Usually it will be in the smaller size, either 4 MB, 16 MB, or 24 MB, not more than that. And the most consuming components of the SGA are database buffer cache and shade pool. So I'll make it as 100 MB. So whenever you issue this startup command, Oracle will look into Oracle home/dbs location, and it will check for this file or this file. So for example, if there are two files present in this location, if there are init test.ora as well as sp file test.ora, then sp file will take higher precedence. So it will open sp file test.ora, and then it will read the content. That means it will read the keys as well as value, and then it will build up the SGA using those values. Okay. Oracle Home slash DBS. So here I have a file called as sp file dev.dr.ora. Okay, so my database name here will be ps-f grep. Okay, give me a second. This is a different server, so let me start. Okay, until then, here on this server, I have a database called as dev.dr. So that is the reason why in Oracle Home slash DBS location, I have a file sp file dev.dr.ora as well as init dev.dr.ora. Okay, now if I issue startup command, so we'll see what will happen. Okay. As the database is not yet started, it will say it is connected to an idle instance. Now, no more. So actually, when SGA will be allocated, we already know an instance is nothing but SGA plus background process. So when an instance will be created, so actually whenever you issue the startup command, it actually goes through three phases. One of the phase is called as no mount phase. The second phase is called as mount, and the third state is called as open. No mount is also called as started. So these are the three phases through which a database startup will go. These are the three steps it will follow. First, it will go into no mount state. In this state, an instance will be started. That means SJ will be allocated and background process will be started. So if you want to issue the startup one by one, then you can also go ahead and use startup with no mount option. So this will start the database in no mount. That means only instance will be started. Okay. So first I will issue this command startup no mount. Okay, now the moment I issue the startup moment, it actually took some time because my system is slow today. So the moment I issue the startup no mount option, it says Oracle instance is started. That means SGA is allocated and the total SGA allocated for this instance is 418 MB. So if you issue startup no mount command, it will show you that instance is started as well as it will show you how much SGA is allocated. So the total system global area is 418 MB. Take off 3 digits and 3 digits. So 418 MB. In that, the fixed size, that means the fixed global area is 1.3 MB. And the variable size, it actually, you need to include the database buffer cache too together. So the variable size altogether, it will be 281 MB plus 130 MB, which counts to 420, around 400 MB altogether. So the total SG allocated is 418 MB, and in that database buffer cache size is 281 MB, and rest of the component size altogether constitutes 130 MB. And now, in order to check instance is started means SG is allocated as well as background process are started. So in order to check whether the background process are started or not, so usually the background process will be of the form aura underscore database name, which is devdr. So the background process starts with aura underscore devdr. So that is the reason why to the ps-ef grep command, uh, to the ps-ef, I'm giving the output of ps-ef grep command to the grep. Did I did I show you how to use pipe? I guess I did.
Yeah.
Yeah. So output of this command will be given to the grep command, and grep will search for aura underscore devdr. So ps-ef will give you all the process which are running on the server, but I am interested only in the background process. And as already said, the background process will be of the name aura underscore devdr. So one second, maybe I'm done. Okay, yeah, it should be aura underscore star devdr. Okay, I'll do one thing. I'll grep for aura underscore, and then I will again grep for devdr. So this will give me the background process which are associated with devdr instance. So all these are the background process. So in order to check whether the instance is started properly or not, you need to make sure the background process are started as well as SG is allocated. So you'll know SG is allocated from the startup command itself. It will show you how much SG is allocated. In order to check whether the background process are running or not, this will be the command ps-ef grep or underscore and then grep with devdr, which is the database name. And in that we already saw dbwr, which is this one. It's a database writer which will write the dirty buffers from buffer cache to data files, and log writer will flush the redo content from log buffer to redo log files. smon will perform instance recovery. Whenever there is power failure, it will try to replay all the transactions which are present in the redo log files, such that the database will have all such that the database will have consistent data after the power failure. And M1, as already told you, M1 will collect the statistics. Even MMNL. Actually, these two processes will work together in order to gather the statistics, like how many sessions are running, how many users are connected to the database, how much CPU is being used in the database, how much of memory is being used by the process. All those statistical information, these two background processes will gather. Then D000 is nothing but a dispatcher process. We already saw it will be used in the shared server configuration, and S000 will be server process, and PMON will do the process cleanup. So whenever there are any dead process which are associated with any client process, then those dead process will be cleaned up by pmon. The cleanup is nothing but whenever a user is performing an insert or update, he will actually acquire a lock on the table. So the pmon will releases those locks on the table, as well as any modified content, insert or update which is present in the memory will be erased, because those are not committed transactions. If it is a committed transaction, then the content from the buffer cache will be flushed to the physical files. If it's not, if it doesn't belongs to a committed transaction, then even the modified content will be flushed. So all that part will be taken care by pmon process. Next, yeah. So if you want to know what file it has used in order to start the instance, whether it used p file or sp file. So to check that, the command will be show parameter sp file. This will show you whether sp file is used or p file is used. So if you see here, the output of the command gave me the location of the sp file, which is oracle home/dbs followed by sp file sid.ora. So that means when I issued the startup no mount option, it used sp file dev.dr.ora. So as I said, in oracle home/dbs location, if I have two files, if I have both the files, init file as well as sp file will take higher precedence. So that is the reason why Oracle started the instance using sp file. If you see here, I have the p file, which is init.dev.ora, as well as sp file. But Oracle started the instance using sp file. Now, if you want to see the size of each and every component, I guess parameter. If I want to see the log buffer size, so show parameter log underscore buffer. This will give me the size of redo log buffer. So log buffer size is KB and then 1, 2, 3. It's around 5 MB. So the log buffer size is 5 MB. So whenever Oracle tries to allocate the SGA, in the SGA, the log buffer component will be 5 MB. In a similar way, show parameter, if I want to see the key pool size. So the buffer pool keep size is, the value is null. That means we haven't configured the buffer pool keep yet. In a similar way, if you want to check the recycle pool, even the buffer pool recycle is not set. That means we haven't configured it yet. Okay, these are, we can see each and every component size of the SGA. I mean, like how much value is specified in the SP file. We cannot open SP file. It's not a text file, it's a binary file. So that is the reason why we cannot open that file and we cannot read the content. So if you want to see what is the value assigned to each and every parameter, then you have to use show parameter space parameter name. This will give you the value associated with that parameter. If you don't want to use this command in order to check the value, then to read the content from a binary file, Unix provides a utility called as strings. Using strings, you can read a binary file. String space sp file dev.dr.ora. This will show you the content which is present in the sp file. So if you see the content, it is actually of the format key and value. So this is the key, db cache size. So 176 MB is assigned to database buffer cache. In the similar way, okay, 1 second. There are two entries here. One is dev dot underscore and the other one is dev dr dot underscore. So only the parameters which starts with dev dr will be applicable for this instance. So dev dr dot underscore db underscore cache underscore size. So the database buffer cache size is of 260 MB. In a similar way, Java pool size is 4 MB. Large pool size is also 4 MB. So this is a way we can read the parameter file using strings option. If you want to read the content of init file, which is p file is a text file. So one of the difference I already told you. P file can be in any location. SP file must be in Oracle home /dbs. And the other difference is P file is a text file. SP file is a binary file. So if you want to see the content in the text file, you can just open it and you can look at it. Okay, so these are the three parameters which are present. Actually, these are the two parameters, actually db block size and db underscore name. These are the two parameters which are required or which must be present in the parameter file. Rest of the parameters, even though you will not specify, they will take default values. So in a parameter file, these are the two must parameters. One is db underscore name and another is db underscore block underscore size. These are the mandatory parameters which are required in the parameter file. Now there are also some metadata views which will show you how much of size is allocated for each and every component. So one of that view is $SGA info. This view will show you how much of size is allocated for each and every component of the SGA. And this view you can only access as this user. You cannot access it through Scott user. So if you want to log in as sys, you can either specify SQL plus sys/oracle as sysdba or SQL plus slash as sysdba. In the feature classes, you'll know what is slash. Now select name comma bytes So this command will show you the size of each component. Okay, let me set the page size also. Okay, so if you see here, these are the sizes of each and every component. And as I already told you, the static component is a log buffer. That is the reason why the resizable column is set to no. And rest of the components anyway will not change it. The fixed size global area, the name itself, it says fixed global area. And you don't need to worry about these three components. This will be Oracle internal components. So the only static component is redo log buffer and the resizable column is set to no. And rest of the components are set to yes. That means you can change the size of those parameters. Okay, let me make it as 2024. Let me get the output in megabytes rather than gigabytes. Okay, so these are the sizes. Shade pool size 116 MB and buffer cache size is 268 MB. If you want to check the summary of SGA, you can also check that using show SGA. This will just show you the total SGA allocated and how much is the fixed size, variable size, and database buffer cache size. So either you can use this show SGA to summarize the things, or you can query v.sga info to get the size of each and every component. Next. Shade pool, we already know there are two components. One is library cache and another is dictionary cache. You can only set the size for shade pool but not for the internal components. Once you set the size for shade pool, it automatically manages those two components. You cannot manage the two internal components of the shade pool. You can only manage the shade pool size, but not library cache size and dictionary cache size. This I'll make it as optional components and then fixed SCA. Fixed global area, FGA, and optional components. Now, sizing of each and every component of the SGA is very important. If you undersize the database buffer cache, it will impact the performance. Because the main concept of database buffer cache is to reduce the physical input outputs. So if you undersize the database buffer cache, as a result, database writer needs to continuously flush the dirty buffers from database buffer cache to write it back to the data files. And also, server process needs to perform large amount of physical input outputs in order to access the objects from the physical storage. So sizing each and every component, even the shade pool. So if you undersize the shade pool, the parsed SQL statements, the compiled version of the SQL statements will not be present in the library cache. As a result, each time you issue the query, it needs to be parsed again. It needs to be compiled. So in order to properly configure these components, till Oracle 9i, as a DBA, you need to monitor the performance and you need to set these parameters till Oracle 9i. So you'll go through trial and error method. So first you'll set the database buffer cache size to around 200 MB, and then based upon the performance or based upon the database buffer cache usage, you will resize the buffer cache in a similar way each and every other components. But starting from 10G, Oracle introduced automatic shared memory management, which is called as ASMM, automatic shared memory management. So in order to use this feature, you need to set two parameters. Again, these two parameters will be present in the parameter file. One of that parameter is SG underscore target. And the other parameter is SG underscore max underscore size. So these are the two parameters which are involved with automatic shared memory management. So by setting these two parameters, we can enable automatic shared memory management. So depending upon each and every component usage, Oracle will internally manages each and every component. You don't need to monitor the components, you don't need to monitor the database performance in order to configure each and every component. Oracle by itself, it will check the usage of each and every component, and based upon the usage, it will either reduce the size or it will increase the size in order to improve the database performance. So SGA target is nothing but how much of size will be allocated for all the components of the SGA. So if you set SGA underscore target to 400 MB, this 400 MB will be distributed among all the components of the SGA. Initially, whenever you start up the database, whenever you issue startup, this 400 MB will be distributed among all the components, and then thereafter, depending upon its usage, it will resize each and every component. Either it will reduce or increase. Okay. Then SGA max size is what will be the maximum SGA size. So say for example, if I set SGA max size as 1 GB, that means you will not have SGA with size 1 GB. You will have the size as 400 MB only. But in the future, if the total SGA of 400 MB is not sufficient for the Oracle database, then you can increase SGA underscore target until SGA underscore max underscore size. Only for that SGA max size will be used. This will determine how much, until how much you can grow the SGA, until how much you can increase the SGA underscore target parameter. The total SGA allocated will depend upon SGA underscore target parameter. But if you want to increase the SGA underscore target itself, it will depend upon SGA underscore maxes parameter. So if you have SGA maxes set to 1 GB, then SGA underscore target can grow until 1 GB. And ASMM will not automatically manage this parameter. You need to set this parameter, SGA underscore target. All the components of the SGA will be automatically managed by ASMM, which is automatic shared memory management. And this will be implemented by the background process MMAN, memory manager. Depending upon their usage, it will automatically manage each and every component. But not all the components of the SGA are managed by automatic shared memory management. Only the components which are database, buffer cache, shade pool, large pool, and streams pool. These are the components which are automatically managed by Oracle. And actually these are the only components which will be most frequently used, or these are the most important components of the SGA. So whenever ASMM automatically configure these components, that's it, we are done. We don't need to tune rest of the SGA components because those are very rarely used. Okay, ASMM automatically manage these 4 components: database, buffer cache, shade pool, large pool, and streams pool. Now, if you set SGA underscore target to 400 MB, then you also need to set the optional component sizes, because optional components will not be managed by ASMM. So that means if you want to have key pool component in the SGA, in that case you will specify the value for keep underscore pool underscore size. So if I specify key pool size to be 10 MB, then this 10 MB will be deducted from 400 MB, and rest of the 390 MB will be allocated among these 4 components. And not only that, first it will deduct from first log buffer. Log buffer will be 4 MB, because even this is a mandatory component of the SGA. The 3 mandatory components of the SGA are log buffer, shade pool, and database buffer cache, apart from fixed global area. So now if the log buffer size is 4 MB, and fixed global area is also 4 MB. So 18 MB altogether will be deducted from 400 MB, and rest of the size will be automatically distributed among these 4 components. Okay, so if you enable ASMM, you don't need to set db underscore cache underscore size, shade underscore pool underscore size, large underscore pool underscore size, and streams underscore pool underscore size. Those will be automatically managed by MMAN process. Do you have any questions till now?
I mean, one question, Mohan, like while changing the variable component like database buffer cache and log buffer cache, if I am changing something, if the size is, I mean, more than the SGA size, what will happen?
It will not allow,
I mean, yeah, okay.
because the total SGA size is 400 MB, and if you want to allocate 500 MB for database buffer cache, it will immediately say
Okay.
it cannot allocate database buffer cache of that much size.
Okay.
And remember, if you set SG underscore target equal to 400 MB, you don't need to set DB cache size, shade pool size, large pool size, and streams pool size. It will automatically manage those components. But as I said, it will be automatically managed, these components. Oracle will automatically manage these components. But even you are using ASMM, and if you want to set a minimum limit for each and every component of each and every of these 4 components, then you can configure db underscore cache size, shade pool, large pool, and streams pool. So if you configure those parameters, they will be served as minimum value of that component. For example, if I set db underscore cache size to 100 MB, so all the time 100 MB will be guaranteed for this component.
Okay.
And also depending upon its usage, it will either increase or decrease, but it will not lower than 100 MB. So it will always guarantee the database buffer cache to be at least 100 MB. If you configure those parameters, if you don't configure those parameters, there will be no minimum value.
I mean, where we will set these parameters like SGA underscore target and SGA underscore max.
Yes. So these parameters will present in parameter file, and if you want to change any parameter which is present in the parameter file, we will use the command alter system set. For example, if I want to set the SGA target, I will use alter system set SGA underscore target equal to 400 M. So this will set SGA underscore target to 400 MB. It will also update the SP file to have SG underscore target as 400 MB. In a similar way, if you want to configure database buffer cache, then alter system set db underscore cache underscore size equal to 100 M. So by using this command, you can set the parameters. Now, as I said, the components can be static or dynamic. So if it is a static component, if you want to change the log buffer size, then the command will be alter system set log underscore buffer equal to, for example, I want to change from 4 MB to 16 MB. Then I'll specify alter system set log underscore buffer equal to 16 M. Not only that, we have to specify scope is equal to SP file. The reason for this is log buffer is a static parameter. You cannot change the value which is already present in the memory. You can only change the value for SP file. You cannot change it for the current existing instance. So that is the reason why you have to specify scope is equal to SP file. That means it will change the value in the SP file, but not it will change in current instance. So once you shut down the database and you bring it up again, it will read the new value and it will allocate the new size for the log buffer. So that is the reason why you have to specify scope is equal to SP file. So whenever you don't specify the scope clause, by default, it will take both. So basically, whenever you are setting parameters, the scope clause can take three values. One is both, second is SP file, third is memory. If you set scope is equal to both, that means it will change the value for the current running instance as well as SP file. If scope is equal to SP file, it will only change the value in the SP file, but not for the current running instance. That means if the instance is already started, and if the database buffer cache is 100 MB, and if you specify scope is equal to SP file, it will not change the buffer cache size for the current running instance. It will only change it in the SP file, such that the subsequent startup of the database will have the new value. And scope equal to memory means it will not change the value in the SP file. It will only change for the current running instance. So if I set alter system db cache size equal to 100 MB and if I specify scope is equal to memory, it will only change the database buffer cache size for the current running instance. Once you shut down and you bring it up again, the size will be changed back to its previous value. So initial value of database buffer cache is 50 MB, and if you change the database buffer cache with 200 MB, after the subsequent startup, that means after the bounce of the database. Bounce means shutting down and bringing it up again. So after the bounce, again the value will go down to 50 MB because you are changing the parameter only at the instance level. Okay, these are the ways you can change the parameter.
Yeah.
Okay, then I'll wind up the class and I'll continue tomorrow. If you have any questions, let me know.
Okay. Okay.
Do you guys have any questions?
I mean, not related to this session. Just I need some help to regarding. I mean, to install the SQL developer.
No,
Just
just
some small
no.
info.
You just need to download. I uploaded it in the Dropbox. You just need to download the SQL developer and just open it. That's it. It's a exe
Okay.
file.
I've downloaded from Google and just I'm trying to install that. Just some getting error like status failure, test fail, IO error. Network adapter could not establish the connection.
Okay, do one thing. The folder which I uploaded into the Dropbox.
Okay.
Once you go into that folder, I mean like once you
Okay.
unzip the folder, you will
Okay.
have SQL developer folder like this one. SQL developer hyphen 3.0 something. Then open
Okay.
this one. Go into SQL developer folder and you will have exe file.
Yeah.
Just double click this one. That's it.
Okay.
You don't need to
Okay.
install. It's a exe file.
Yeah. Okay. That's fine. Yeah, that's fine, Mohan.
Yeah. Okay then. Bye.
Okay, bye.